Alright, let's have a look at these examples. You will have to try them. Example 1. You are given ABCD is a rectangle. DC is produced to E. A is joined to E to cut BC at F. You are required 1.1. Complete. AB is parallel to two other line segments. 1.2. Prove triangle ABF is similar to triangle ECF. That's number 1. Then we look at number 2. We're looking at the figure. You have a right angle triangle ABC and BD is the height. And you are told let angle A equal X. Prove ABC is similar to ADB. Prove that ADB is similar to BDC. Alright, you can stop the DVD here and try them and then come back to us for a review. Right. Let's see. Well, I trust that you stopped the DVD and you tried the example. Let's see. ABCD is a rectangle, so we start with that. This is called a keyword. Keyword. It's a rectangle. If it's a rectangle, that means I have to mark this 90, mark that 90, mark that 90, mark that 90. I can also mark the sides equal, but I'm not interested in that today because I'm doing similar triangles, and in similar triangles I'm only interested in angles. So I'll only mark that. Now, so that's a rectangle. But anyway, out of interest, this side is equal to this side, the whole side, and this whole side is equal to this whole side. I don't need the sides. DC is produced to E. DC is produced to E. That means DCE is a straight line, and therefore this angle is also 90. That's what it means. It means that angle is also 90. And now, so, and A is joined to E. A is joined to E. Now if A is joined to E, then this is a straight line. Alright? And let's see what happens. Well, by the way, this line is parallel to this line because it's a rectangle. This line is parallel to this line. And now, because this is produced, then the produced part is also parallel. So let's see what they wanted to know. Complete AB. AB is parallel to what? It's parallel to this side, to DC. So it's parallel to DC. Then they say AB is also parallel to another line. AB is also parallel to this whole line. And that whole line is called DE. So AB is parallel to DC, the small part. It is also parallel to the big part, DE. Now, required to prove ABF is parallel to ECF. ABF, required to prove. So they're talking about this triangle here. Prove that triangle is parallel to ECF. ECF is this triangle here. Now, one thing is clear. You can see there's a 90 here and a 90 here. So we got one angle. Now we're looking for another angle. Well, look carefully. This line is parallel to this line. Therefore, this angle here is equal to this angle here, alternate angles. So now we have 90x, 90x. Also another thing, this is a straight line because it is one side of a triangle, a rectangle. It's a straight line. And this is a straight line because it was joined, A was joined to E. Therefore, even this angle is equal to this angle, vertically opposite. So you can mark whatever you like. So this one is Y and this one is Y. So always try to mark your angles equal. And now we want to prove ABF is is similar to ECF. You can see clearly there's 90, there's 90, there's X, there's Y, there's Y. So we can write the proof. Required to prove triangle ABF is similar to triangle ECF. 1. Proof. Angle E is equal to angle A1. I'm starting from here and looking there. And no, since I wrote ABF first, I will look from this side. Angle A1. Angle A1 is equal to angle E. Reason? They are alternate angles. Number 2. In fact, if you like, I can even say which lines are parallel. AB is parallel to DE. Sometimes it's nice to say which lines you're looking at, so the person who's marking can quickly check and make sure that he gives you the mark. And number 2, a B is equal to angle C2. Reason? Straight line and rectangle. Let's explain. B is 90 because of rectangle. C2 is 90 because of a straight line. This is 90, therefore that would be 90. 3. F1 is equal to F2. Reason? Vertically opposite angles. Therefore, triangle ABF is similar to triangle ECF. And now we have to write the ratio. The ratio, the first two, AB over EC is equal to the next ratio, BF over CF, which is equal to the last ratio, AF over EF. Right, you see, each one is called a ratio. All three together like this, or two together like this, is called a proportion. This is a ratio, this is a ratio, this is a ratio. But all three together, or just two together, is called a proportion. So, prove your triangle similar, write down your proportion. It's a very good habit to always write down the proportion. Alright, let's move on to the next diagram. Now, you are told that ABC is a right angle and it is right angled at B, so it's marked 90 already. BD is the height. If BD is the height, this is a key word. It's a height means these angles are 90. 1 and 2. They are 90. Height forms a right angle. And they say let A1 equal to X. So this is X. There, right? We marked. Now let's see. They say prove ABC. ABC. That's a big triangle. ABC. is similar to ADB. When two letters are repeated, there could be a common angle or there could be like vertically opposite angles. So if we look carefully, A belongs to this small triangle and A belongs to the big triangle. So A is common. When we want to prove that ABC, the big triangle, is similar to the small one. So in the small one we got X and 90. In the big one we got X and 90. Or you can just say that A is common. So let's write the proof for 2.1. Required to prove A, B, C is similar to A, D, B. Your proof 1. Angle A is common. You must learn this common thing, very important. Angle A belongs to the small triangle. Angle A belongs to the big triangle. So angle A is common. So that's 1. 2. D2 is equal to B is equal to 90 degrees. Reason, one was given and the other one is due to height. And number 3, the remaining angle. So what is the remaining angle? Let's call it B1, B2. So B2, the remaining angle will be equal to C, because these are remaining angles. Therefore, triangle ABC is similar to triangle ADB. Angle, angle, angle. Well, let's see, the labeling is correct. ABC means X 90. ADB means X 90. It's correct. Proportion. First two, AB over second two, AD. Second two, BC over second two, DB. First to last, AC over first to last, AB. All right. So you can do that. Now, why did they say make X 90? It's very interesting why they said that. Let's go back there and see why. They said let this be 90. I mean X. This is 90, this is X. Therefore this angle here, sorry about that. Therefore this angle here, according to angle sum of triangle, if that one is 90, then these two also equals 90 added up. Therefore this angle is 90 minus X, angle sum of triangle, right? Or if you say no, show it to me step by step, then this angle B2 is equal to 180 degrees minus that one 90 degrees minus that one X, which is equal to 180 minus 90 is 90 minus X. So B2 is 90 minus X. So this is 90 minus X. So you're looking at the small triangle. Now when you look at the big triangle, this is 90 and this is X. Therefore angle C is also 90 minus X, just like this. Angle C is also 180 minus 90 minus X. Alright, let me just show it to you step by step so you'll believe me. C is equal to 180 degrees minus this 90 minus that x, which is equal to 90 degrees minus x. So C is also 90 degrees minus x. Right. Now, required to prove. Required to prove. Triangle ADB. Triangle ADB is similar to triangle BDC. Proof 1. Right, let's look at this. ADB is this triangle here, this small triangle here, is similar to BDC, is that small triangle there. So this small one and that small one must be proved. So you can see clearly that D1 is equal to D2 is equal to 90 degrees. Reason? Because of height, HEIGHT. I hope this is visible. I hope this is visible. Right. Then number 2, this is 90 minus x, and that is 90 minus x. So B2 is equal to C. B2 is equal to C is equal to 90 degrees minus x. The reason is angle sum of triangle. Then number 3, the last one. So we said this, we said that and that. So this is A. Angle A is equal to angle B1. Those are the remaining angles. Therefore, triangle ADB is similar to triangle BDC. Angle, angle, angle. And now the proportion, first two, AD over BD is equal to second 2 DB over second 2 DC is equal to first to last AB over BC. Alright, so let me just go across and then you can have a good look at this and get it fixed in your mind. Alright, with that we're going to come to the end of similar triangles. You must be able to prove triangles similar. Use your previous geometry that you have learnt, and after proving triangles similar, always write down the proportion. Write down the proportion. Remember that that's the proportion, or this 2 forms a proportion, or all 3 form a proportion. But this alone is a ratio, that alone is a ratio, that alone is a ratio, but all 3 together is a proportion, or any 2 together. Any 2 together will give you a proportion. Alright, thank you very much, and with that we come to the end of similar triangles. In the future DVD, you will see how we use similar triangles to calculate the lengths of sides, but that is not our topic today. Today our topic is just to prove triangles similar and to write down the proportion. So we have done that. So thank you very much and all the best to you.